Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in HPC, here in AWS. This week I'm joined by Alex Kimber from our FSI group in London. Hey Alex, how you doing?
Hi there, good to see you again.
So Alex is our go-to guy when it comes to talking about FSI HPC, and we recently we had a chat a few weeks ago where you gave us sort of really good sort of basic introduction to sort of the evolution and as you've seen it. And actually, you know, strangely, the outcome was sort of a bit circular, right? They ended up in an interestingly similar place than where they started, but for very different reasons, and a lot of stuff had happened along the way. I think we mentioned at the end of that discussion that we were going to come back and talk about the role of serverless as being a pretty key technology.
As you said, the challenge of the financial services, high performance computing has evolved over probably a couple of decades, of which I've been able to sort of have a first-hand seat at some of those developments. Yeah, we started off with spreadsheets. You would be astonished just how many businesses are run purely off spreadsheets, and this is where this technology started as well. But spreadsheets, quickly ran into scalability issues and auditing issues. And so we saw this evolution through into compute farms where different business units would have small pockets of compute to enable them to scale out as they ran these simulations. And ultimately, they converged on these multi-user grids because the farms were fairly inefficient. If you had one user group who wanted a lot of capacity and another that was idle, they weren't able to share. And so the multi-user grids were a great way to converge those technologies. And that's kind of where things stand today for a lot of firms, and they're just, of course, starting to explore, how cloud can help in this picture. So as you move to the cloud, the game changes in two key ways. So firstly, those scheduling decisions get a lot easier when you've got limitless capacity because you're not having to make trade-offs or prioritization calls about who gets the capacity, because if you've got theoretically limitless capacity, you just kind of go ahead and schedule the thing. But the other thing is that granular ability to scale capacity means that you don't have to, that concern around centralizing for efficiency is just much less important, because if you can spin up a small cluster for every different business line, but be very confident that you can scale the capacity according to their precise needs in a really granular way, then it's pretty efficient anyway, so you don't lose out on a lot of efficiency gains that you would have got through centralizing. So again, it just makes it a bit simpler. So what I'd like to talk about some more is grid schedulers. So I've been trying to get a Monty Python reference into to talk for a long time. So I've found my opportunity now. So
I doff my hat to you. This is awesome.
So grid schedulers are not to be underestimated, right? The typical schedulers that firms are using today are very capable bits of software which do an awful lot for you. We talk about things like task scheduling. That's kind of the obvious one, and that really is, how do I make really rapid decisions about where I place these tasks? How do I manage the queues of tasks? How do I manage things like the life cycle? So if there's a failure, how do I manage retries, things like that? So that is a lot of value add. There's a lot of complexity and engineering that's gone into that, and it's something that these grid schedulers.
When you talk about making rapid decisions about task scheduling, let's give everybody a bit of context there. How many jobs are we? How fast are the jobs coming at this thing that we're talking about?
Yeah, I mean, it's pretty typical for these schedulers to have to handle thousands of jobs a second. So, 2, 5, maybe even up to 10,000 tasks a second is pretty typical. And those decisions have to be made very quickly because a lot of those jobs are very short. So if you've got a job that's 300 milliseconds long and you spend 200 milliseconds just making a scheduling decision, then that's a massive overhead in terms of the overall time to get a response. Yeah. The injection rate is very important if you've got a risk management system that needs to do that kind of asynchronous call to just say, look, here's a load of stuff for you to go and do while I go off and do something else. Mm-hmm. But the total turnaround rate is really important on, say, an intraday pricing job, right, where you have a customer on the phone who wants to know how you're going to price this complex financial product. That turnaround time then is particularly important. So your grid scheduler needs to be able to make those decisions, and that high throughput is really important. So the other part is data distribution, which we talked about earlier, which is how do you get the right data to the right piece of compute at the right time. There's all sorts of efficiencies you can start pulling in there. So as we said, don't copy the data thousands of times if you can avoid it. Try and get it landed into the cloud just once. as you sort of advance through maturity of this, you can potentially do things like data-aware scheduling. So if there is a compute node that already has that data locally, then favor that in terms of scheduling tasks. There's a lot that the schedulers have done there to try and improve the data distribution. Binary package management sounds kind of straightforward, right? I just need to get my binaries out to my compute, but it does get challenging, partly because potentially you might want to have different versions of binaries out there for different purposes. So in my previous career, for example, we would have a production set of binaries, which is running the day-to-day business, but potentially non-production binaries running alongside them, which are being used for test. So they're doing during the day when the grid is relatively quiet and it's doing production intraday pricing workloads, but it's relatively lightly utilized. Being able to run non-production workloads alongside those to validate models is really helpful, helps drive up utilization. And again, with great task scheduling, you can make sure that the production workloads are always prioritized. But the other really important thing is auditability. So within banks, you need to be very confident that the analytics that you've tested and validated are the same as the ones that run in production. And you need to be able to say, on this day, this calculation ran with these binaries, and be super confident that you actually use the right versions to get the results.
Right. This is a banking version of provenance that people working in life sciences are well familiar with. Is the ability to say, for this scientific paper or this conclusion that we made about a vaccine, here was the data and here were the binaries and the executables that led to that conclusion.
Absolutely, yeah.
This is like a complex thing for a lot of banks because it's expensive to do that certification to make sure that those binaries are, produce the right answer, the same answer as, say, a previously compiled version. And it does get down to versions of compilers and math libraries and stuff like that, right?
Yeah, exactly. Yeah, and you need to have that sort of governance and that end-to-end traceability of what ran when and what versions, and be super confident about it. The other part is infrastructure orchestration, which typically on premises is managing a relatively fixed set of compute nodes. Although in my career we've done things like CPU harvesting from workstations, so it can be a dynamic pool, and being able to manage what happens if an instance disappears off the network or if a new instance comes back up. How do you then make sure it gets married up with the latest binary packages before it re-enters the cluster? All that kind of stuff is typically handled by the grid scheduler. And the last bit is telemetry and control, which again is easy to forget, but one of the most common questions I had in my career was, what happened to my task? And when you're handling hundreds of millions of tasks a day, being able to look in and say, actually, this is what happened to your task, here's how far it got, or maybe here's the nature of the failure, and ultimately and ideally making that self-service so that traders can see for themselves what happened to their task is really useful.
Okay, so we've got services that map onto these things, right?
Yeah.
This is not our first rodeo.
Yeah, I was trying to think how to. I came up with these are not niche requirements, but not a first rodeo is a good way of putting it as well, right? These problems are things that have been solved in other technical spheres, right? The ability to asynchronously dump a load of workload onto a queue is not a new concept at all, and services like SQS, are very mature and been around for a long time and have been demonstrated that they're robust and scalable. They can help solve a lot of these problems.
Yep. Now we've got an asterisk next to batch there, and I think the thing worth saying there is, batch seems like an obvious one to go to when you're talking about task scheduling, but batch wasn't designed for an injection rate of 100,000 jobs in a couple of minutes, with an average job time of like you said before, 300 milliseconds. I mean that would be a pathology to batch as things stand at the moment. So I guess we just want to explain why that asterisk is there.
Yeah.
But what about the rest? What about, because I think, like you say, the task scheduling, it seems kind of obvious that SQS and Dynamo are the things there. What about data distribution and in particular package management?
Yeah, I call that a couple of services here, and I think the overall message of this slide is you have options, right? There are different ways you can plug these building blocks together to solve the problems that that are specific to your organization. But if you take S3, for example, it's tremendously robust. It's automatically replicated across 3 availability zones. So if you have your infrastructure spread across your region, there's a good chance it'll be able to get hold of that data in a location that's close by. If you really want to go for extra high performance, then you've got FSx for Lustre. We have customers looking at Elasticache for Redis as well. So again, you've got different options. Binary package management is an interesting one because I think it depends on what your end compute is. So if you're just running EC2 instances, then perhaps you can package your binaries in an Amazon Machine Image or an AMI, and then they're just there as the machine comes up. If you're looking at container-based compute, then ECR is a great way to go, because again, it keeps track of those containers, and gives you that auditability, right? So you know that ECR image.
Do we have a number of banking customers using containers?
It's an increasing trend. It's quite interesting. I think we're seeing customers exploring serverless. They're exploring how to provision this infrastructure, and I think containers are gaining a lot of traction. So we definitely have customers in production running container-based workloads for HPC. It's definitely a trend. I think people see it as part of a spectrum, and there's another sort of image later on that kind of shows how we see these things fitting together. I'll just talk about the infrastructure orchestration again, because I think it also speaks to like how you deploy your compute. So again, if you are deploying EC2, one of the things that just makes a massive difference for customers is auto scaling, right? So we think of it as a pretty straightforward service, but it not only is tremendously powerful and has a lot of flexibility in the way that you provision infrastructure, but it also just takes away a lot of the manual heavy lifting, I guess, of infrastructure management. So the ability to have AWS auto scaling, scale the infrastructure up and down according to the demands of the day, and do so in a very rapid and granular way, really makes a big difference. So even if you're not going down the whole full-on serverless route, there's still an awful lot to gain through things like auto scaling. And then, of course, you've got Fargate, which will manage containers for you. And then at the other end of the scale is Lambda, where we can talk about that in more detail. But there's no infrastructure to manage; it's inherently granularly scalable.
So I guess the obvious evolution of all of this has been encapsulated into your idea of how to do this, which is the HDC Grid stuff, right?
HDC Grid is something that we built in collaboration with a financial services customer who was looking at just how they wanted to evolve as they moved into cloud. And so HDC Grid is an open source project which is available on GitHub. You can go and have a look at it. And it's made up of a series of AWS services plugged together to build the things that you need out of your grid scheduler, but in such a way that's pluggable. So we don't mandate that you use S3 for your storage. Perhaps you could plug in Redis. It doesn't mandate that you use EKS. You could use EC2, or perhaps you could plug in Lambda for your compute. So it enables you to start experimenting with these things, and also demonstrates what can be done using some of these standard primitives. It's worth saying it is a blueprint. It's not an AWS service, but it's obviously built on well-trusted and well-established AWS services that are well known in terms of their capabilities of scale and availability. And it's relatively straightforward to understand. You can have a look at the code. You can pull it apart and see how it works, and see if it'll work for you. And we hope that it's something that'll be extended over time.
All right. So where does that leave us? I guess
there's a term that a colleague coined, which is this kind of convergent evolution of compute, which I quite like. And convergent evolution is something that's come out of sort of natural history and how animals converge into solutions to problems like flight independently, even if they don't have a sort of common parent. And I think we're seeing that with financial services as well through the conversations I'm having. There is this kind of mental model of, okay, I moved to cloud, I moved to EC2, that's kind of familiar. Maybe I need to re-engineer for Linux. Maybe I want to explore things like GPU some more. Or maybe Graviton 2, which is also gaining some traction. But then they start thinking, okay, well, containers is another option. I like the idea of Fargate and kind of removing the need to manage the infrastructure. That has some benefits. Maybe they start looking at EC2 Spot to try and enhance their price model. But slowly things are converging more towards serverless, because with HPC, the less that's involved, if you can add simplicity and lightness, then you're going to get a better result. And so in the spirit of adding simplicity and lightness, we do tend to converge on serverless infrastructure, and in particular Lambda. That just seems like the logical endpoint for this stuff, that as little as you have to do as possible, and the ability to scale super quickly and in a really granular way, just fits these workloads so well.
The last things to say is, if people want to get more information about this stuff, obviously, now you've written a blog about it. The blog's up at this URL. This is the short code that'll take you straight to the blog post that Alex has written that's describing a lot of this stuff. And if people really want to, if they find that interesting and want to chase down on it and start to evolutionize, and I'll say it's evolutionize rather than revolutionize their HPC workloads, they can just reach out to their AWS folks, right?
Yeah, sure.
Thank you for coming along today. This was good. I continue to learn more about the financial services industry every time I talk to you about this stuff.
Yeah, my pleasure.
All right. Well, so if anybody out there is looking for us to cover different ideas, if there's extra topics that you want us to dig into in future Tech Shorts, DM us on Twitter. Our DMs are open. Anyway, for now, Alex, thanks for coming along. I guess we'll see you next time.
Yeah, see you next time.
Thanks.
Bye.